Greetings everyone, this is Non-Expert here back again with another video. Today we are going to be solving problem number 12 of our main LeetCode challenge, and the problem that has been given to us today is a single element in sorted array problem. Again, if you want to try solving this problem on your own, you can pause this video and check out the LeetCode link given in the description below, and let's get started. So the problem description is that you're given a sorted array consisting of only integers where every element appears exactly twice, except for one element which appears exactly once. We need to find the single element that appears only once. So you've been given an example over here where you have a sorted array and you can see that everything's sort of coming in pairs. So you have double one, then two, then double three, double four, double eight, and the element that we're looking for is two because it occurs only once. So this is a very straightforward problem to understand. But you've been given a note over here which states that your solution should run in O of log n time and O1 space. So obviously, if this constraint wasn't given to us, you could have sort of maintained a counter and you could have just implemented that. But unfortunately, you have to abide to the restrictions which have been given over here. So obviously, since we know that this array is sorted and the time complex is going to be log n, we know for a fact that we're going to be using a binary search problem. That's pretty straightforward to understand. And since we already have that intuition, let's try to perceive an implementation that we could sort of use. So before we start, let's just have a look at the input array itself. So let's just go ahead and copy this and let's just paste it over here so that we can play around with it. So all in all, if you look over here, what's happening is that you have a bunch of elements, and if you look at the mid is this guy over here. Now, since we know for a fact that we have nothing but pairs except for one, we know for a fact that the length is always going to be odd. That's something that we can always leverage. So if we make sure that the mid value is something that we're picking out as the odd value inside the indexes, that's something that we can use. And that assumption actually holds pretty well. So if we have this array, you can see over here that the midpoint is actually this 3 that I've highlighted over here. And this 3 actually comes at the fourth index when in a zero index array. So what that sort of helps us do is that we can analyze to see where exactly does the element reside under the single element that we're looking for. So before we do that, let's just do a quick experiment. Let's say that we don't have this 2 over here, and this is a sorted array. Now let's say we do paste the 2 over here. So the only thing that happens is that, as you saw in the pasting, that everything after 2 sort of got shifted forward by 1, and everything before it was the same. So keeping that in mind, we can use that algorithm to identify where we need to move as well. So if we say that whatever's at the mid, and let's just say that's going to be nums mid, and we say whether it's equal to nums mid plus 1, so we're just checking for the next value. Well, whenever that would happen, whenever that's the case, we can say for a fact that we need to move on the right side of our subarray, and on the left side if this condition does not hold true. Another simple example for this could be if I can just copy this and paste this over here. So we have another example. So let's say we are pasting 6 over here. And as you can see over here that the midpoint would be this guy over here. So when you check the next element, it is actually equal. And you know for a fact that when that's equal, you don't really need to look at the left anymore. You need to look on the right. So we just update our values and then we move forward with that implementation. I hope that's clear, but that sort of helped me out as well. One other thing that we also need to make sure of is that we need to make sure that the mid element that we're presently on is always satisfying our main condition. That's something which is a little tricky to do, but when I write it down, it's going to be a lot more easier for you to understand. So let's just start with a base condition. We're just going to say, hey, if nothing has been given to us, then we return nothing. I'm also going to put a quick condition which is just going to say that if the length of nums is equal to 1, then you just return whatever's in the nums because we don't need to do any iterations over there. And now what we're going to do is we're going to set our low and our high value, which is something that you always do in a binary search problem. So let's just do length of nums minus 1. And essentially what you want to do is you just want to do a loop for from low to high, and that's just something which we always do. So keeping those things in our into our consideration, now what we want to do is we want to implement a logic, and do note over here I'm not doing low less than equal to high, I'm just doing low. So that would mean that eventually what's going to happen is that the low value that I have that's going to be the breakaway condition. That's something that we need to return as well. This is something like simple binary logic, which we have to like use. So now let's just go ahead and set our mid. So setting a mid is actually the tricky part over here. So when we do low plus high, which we usually do in most scenarios, we do uh, division sign by 2. So that also returns an integer to us. Now that sort of gives us a potential problem, and I think you can guess what the problem would be. So the problem is that, well, if we can leverage the fact that we always want our mid to be updated, we can either control it to always have odd indexes or always have even indexes. The way to do that is actually by putting a simple mathematical operation. So you can just do 2 into divide by, at least instead of divided by 2, you're dividing by 4 and you multiply it by 2. So what that does for us is it always gives us the even index. So if you look at this particular logic over here, what we would want to do is we would want to find the even index or the even mid index, and when that happens, we can sort of clarify this condition as well. So that just makes sure that no matter what happens, our mid is always even. That is something that's a simple trick, but once you have that, this condition becomes a lot more easier to take care of. You don't need a lot more if this is a little confusing for you, you can have a lot more if conditions where you'll have to consider when mid is even versus when mid is odd. But I find this approach a lot more easier. So when you have that, what you just have to do is you just have to check for whether the next value of our mid is same as whatever we have on our mid. If that's the case, then we update our low, because the left subarray does not really correspond to, or at least does not have the element that we're looking for. So we update our low. Otherwise, what we're trying to do is we're just going to update our high and we're just going to make that as mid. So do note over here, I'm using this high equal to mid and not mid minus 2. And the reason behind this is how I'm sort of returning the values. You can implement it in your own way. You can also have like if conditions for nums mid equal to not equal to nums mid minus 1, uh, and not equal to nums mid plus 1 plus. But I just find those things a lot more uglier and difficult to handle because there would always be so much case. So let's just go ahead and run this code, and hopefully this should run fine. And while it's running, let's just quickly go through the problem statement again, like how we've solved this problem. So the summary is that we're using mid, and we are always making sure that we've understood the properties of our array. And the property is that whenever we're looking at a particular element, if the next value is not the same, well, in that case, we need to move or shift forward our high value. So we had an example, the first example that we had 3. And we know for a fact that that's always going to be, we've always made sure that that's going to be even for us. So that's something that we did that was a little smart for us. So when we did that, we always had the actual mid in an odd length array. And what that did for us is whenever we looked at the next value, for example, when we looked at this guy, we know for a fact that there's a shift which has happened in this particular thing. So we updated our high and then we look at the next thing. So the highlighted subarray that I have is the array that we're considering now. And we look at 2. Now what's happening in 2 over here is something very straightforward. And you can see that that's the actual element that we're looking for. But essentially what's going to happen is going to check for the same thing. So it's going to check for the next value which is not equivalent. Then it updates the high. And this sort of just keeps on going forward till low eventually reaches on this element. And that's basically it. So let's just go ahead and submit this, and hopefully this should get submitted. And you can see that's been accepted, and awesome. So I felt like this problem is something that is a little tricky. The first time I had solved this problem was when I had done a lot of if conditions, and I had around 8 if conditions just to handle all the scenarios. But I find this approach a lot more easier just because you have control over, well, how the mid is going to be given to you and how you're extracting out the element that you're looking for. Cool. So if you did have any comments or if you didn't understand something, leave it in the comment section below. And if you did like this video, do give a like and do subscribe to our channel. We are discussion over here and we would love to have you on board with us. And if you've already subscribed to our channel, you're awesome. We all know it, and have an awesome day. Thank you.